Dear friends, dear class, today we start a new course, the Science and Engineering of Materials. I'm Professor Alexander Mukassian, so professor in two institutions. On one hand, I'm professor of Chemical and Biomolecular Engineering at University of Notre Dame, Indiana, USA. At the same time, I'm professor of Moscow Institute of Steel and Alloy, and so will be for your disposal for the next maybe several lectures. So first of all, let us discuss what we are talking about. What is the material science and engineering, or by abbreviation MSE? So immediately let us discuss this very famous tetrahedron, which consists of different elements. You can see that on one hand, so we will talk, of course, about materials, about material composition, their structure, and of course different processing approaches which allow you to obtain this structure and composition. More important, that we will try to connect the structural characteristics of the material with their properties, and even more, the properties under the operational conditions, sometime taking into account also economical consideration. So that's very famous material science and engineering tetrahedron. So again, the relation between the processing, structure, and composition is the field of very famous material science. However, altogether, a structural, a composition, synthesis, processing, properties, and operation is the field of interest of material science and engineering, which we will talk about. So that's the sequence from processing to the desired structure, from the desired structure to the desired properties, from the desired properties to the performance. That's the whole route which we plan to go with you during this course. So again, what is MSE now? You know, that's somehow overlapping of the science of processing, science of structures, science of properties, which all together come to the desired performance. So again, why it's important? On one hand, it's important just because if you analyze the research of any of engineers which you can think about, chemical engineers, electrical engineers, mechanical engineers, bioengineers, believe me, 85% of them are dealing with materials. But we also can look on this problem from the historical perspective, and you know for sure that materials indeed drive our society. Put your attention on this slide, and you can see that ages of mankind, so which you can see on this slide, they do have names, and all these names are related to some specific materials. The Stone Age, the Bronze Age, the Iron Age, Steel Age, so non-ferrous and polymeric materials age, Silicon Age. What will be the next one? This course, I hope, will help to make your guess more scientific. So, in conclusion, we may say that material science and engineering is an interdisciplinary field of science which concern of inventing of the new advanced approaches as well as advanced materials based on the deeper understanding of the unique relationships between the processing, microstructure, properties, and application of these materials. Thank you so much for your attention. It is logical to start a discussion on material science and engineering with classification of materials. This classification is based on your long life experience. Nothing new here, but we have to remind ourselves what actually is going on. Based on our common sense and life science experience, you can easily distinguish three main classes of materials. So metals, ceramics, and polymers. So on this slide, actually, you can see that each of these materials can be used for almost the same applications. So the famous Coca-Cola can be in the aluminum cans, in glass ceramic bottles, as well as in polymer bottles. So why actually it's so? If you think a little bit, you will figure out that it depends on where are you, and in the other word, under what conditions you plan to drink this Coca-Cola. So for example, so if you care most of all on the, let's say, quality or long-time quality, you will prefer the glass bottles. If you think that you will use these bottles for some future applications, I believe polymer bottles will be the best for you. If you think about the easy way to carry the bottles during your long trips, metal bottles will be your choice, right choice. So you can see immediately that different materials can be used under different conditions, and your choice will depend on the operational conditions. So now let's go a little bit further. Metals, again, we don't know why and we don't know how, but in general we know if we are talking about metals or metal alloys, we expect that they should be pretty heavy, so it means that they do have high density. They should be pretty strong, so it means that they have high strength and toughness. Typically, the electric and thermal conduction materials, you know, copper is the best, maybe the normal electric conductive and heat conductive materials. And also, for sure, if you're thinking about magnets, you know that you have to pick up the magnets among the metals. However, if you're talking about ceramics, you will have some maybe different thoughts about their properties. See, we are talking now about materials and properties. So you know that there are a lot of glasses which differ as compared to metals, because glasses typically are amorphous. So again, so density of the ceramics, again, typically is much less than for the steels and alloys. However, glasses typically has extremely high melting point and very high chemical durability. They can withstand in various harsh conditions, and however, they are brittle. That you know for sure, and they do have a relatively low electrical and thermal conductivity. Agree that these properties in general are very different as compared to metals. Polymers, again, based on your long life experience, you know for sure that they do have very low density. They're extremely light. Also, you cannot expect high mechanical property for them. That's why hardness and strength are low. However, you know that they do have extremely high elasticity, and also you know that they're very easy in use, while their melting points are relatively low and you cannot use them at very high temperatures. Also, maybe you remember, or it came to your mind, typically electrical and thermal insulators. So 3 types of materials, very different properties. Question, why? What was used as a base for this kind of classification? This relatively complicated slide, which will come back again in the next lectures, so just provide you some idea about that. Idea is very simple, that materials are not black boxes. They do have different levels of structures, and different levels of structures in some sense defined their property. In particular, this kind of classification which we discuss with you is based on the atomic structure of this material. And next lecture will be devoted for the explanation how actually atomic structure provides you these different type of properties which we talked about. In the next lecture, we will discuss in details how, for example, atomic structure influences their material properties. So while we are talking about structures, it's not bad on the examples discuss this issue a little bit and discuss the relation of this structure to the material properties. So, for example, on this simple slide, you do have typical stress-strain diagram, which you can easily obtain if you apply tensile stress experiment to any kind of material. Based on the analysis of this kind of stress-strain diagram, you can extract very many mechanical properties of the material, including such as Young modulus or tensile strengths or so on and so forth. So that's just in order to refresh your mind about different mechanical properties of the materials. Now, on this slide you can see that, for example, Young modulus or elastic modulus of materials is very different for different type of materials, as you can see. Ceramics, they do have the highest one typically, and so which can even approach 1,000 of gigapascal. Slightly lower typical for metals, and of course you can see that polymers are typically in the bottom of this classification. So when we are talking about the yield strengths, that's pretty similar if you want the picture. Ceramics has the highest yield strengths, so while the polymers the lowest one, and again that's it will be shown that is defined by the material structures of the different of ceramics, metals, and polymers. So what are the level of structures we are talking about? I already mentioned about atomic structure, which we'll discuss in the next lecture. However, of course, we know that we do have the nanostructure of material. The term nano is extremely popular now, and we have to understand what does it mean. But at least from the scale standpoint, you can see from this slide that this scale, which is on the level of the 10 to the power minus 9 meters. Also, we have to talk about the microstructure of the material and, of course, about macrostructure of the material. This level of structures, they are responsible for the different types of material properties. And our first task is defined actually what structure, what level of structure is responsible for what kind of material property. In this slide, the last slide of this lecture, gives you some insight on these relations. For example, one can see that atomic structure actually defines, let's say, Young modulus or elastic modulus, which we discussed before. And the strength of the material is mostly defined actually by the microstructure. Hardness of the material in many cases is defined by the crystalline structure. However, overall property of the material, which includes, let's say, chemical, thermal, and strength durabilities, may be defined also by the macrostructure, as you can see on this slide. So our next task is to move to the atomic structure of the material, when we will try to refresh our mind what does it mean and what properties are defined by this level of structure.